Okay, so we're going to use SOHCAHTOA on sine and cosine, and the definition of cotangent is 1 over tangent. Okay. So sine x and cosine x are defined in terms of opposite, adjacent, and hypotenuse. So tan is opposite over adjacent, so the reciprocal is adjacent over opposite. And if I do divide the top and bottom by hypotenuse, I get what I want. Okay, what does unit mean? Unit means 1. We use the unit circle in order to get beyond 0 to 90 degrees. Let me just say that. Okay, so a right triangle trig can't deal with negative angles, and it can't deal with a right angle and another angle that's more than 90 degrees. Let me try and write that down. So we use the unit circle to be able to define sine of x for any x and cosine x for any x.
And tangent and everybody else.
I know, that was a big info dump. Deal with it. Okay, next one. We have a picture we've dealt with before. The point 3 comma y is in the 4th quadrant, so y must be negative. So over 3 down y. Radius of 7 on my on my circle means that 7 is the hypotenuse. Okay, and that means we can do 7 squared minus 3 squared, 49 minus 9. But that's not quite y, because y is in the 4th quadrant, so y is negative root 40. And then y is opposite, and we want sine and cosine. 3 is adjacent, 7 as hypotenuse. So sine of theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. Okay, which is greater, cosine of 30 or cosine of 40? Cosine is the x-coordinate, and that decreases as the circle is traversed around. So for a little picture, let me attempt to draw a circle again. At 30 degrees, the cosine is something. At 40 degrees, the cosine is less. Excuse the cat, she wants dinner. Okay, this must be arc sine, or at least x equals sine y. In order to get arc sine, it must be sine rather than cosine because it goes through the origin. Cosine, remember, goes through 0, 1, so arc cosine goes through 1, 0. Okay, now, if you look at this, it fails the vertical line test. We restrict arc sine to go from just this one chunk. This height is pi over 2, 1.5-ish, and this height is negative pi over 2. So if you remember from the previous set of notes and problem sets, the range goes from negative pi over 2 to pi over 2. Negative pi over 2 to 0 is the arc sine when we have a negative input. So let's break this all down. The domain is, so the range for regular sine is negative 1 to 1. The domain for arc sine then is negative 1 to 1. Notice x-coordinate goes from negative 1 to 1 only. Range is negative pi over 2 to pi over 2. And that's, remember that negative pi over 2 to 0.
Fourth quadrant.
Is for negative inputs. Negative fourth quadrant angle. All right, arc cosine, notice you can't go from negative pi over 2 to pi over 2. You have to start at 0 and go to, looks like a little more than 3. Oh, that's pi. Okay, so the domain is, once again, negative 1 to 1. Notice the domain of arc cosine is the same as the range of cosine. Not a coincidence. Okay, so notice pi over 2 to pi is the second quadrant stuff. I'd better feed the cat before I make another video. Okay, for arc tan, notice that it kind of looks like tan flipped. We have bottom at negative pi over 2 and a top at positive pi over 2. And notice we do not go through the asymptote at pi over 2 into the second quadrant. So domain for tan, arctan, is the same as the range for regular tan. It's all reals. You can input any number into arctan. The range is just like with sine. Remember, we use negative angles for negative inputs. And angles between 0 and 90 degrees for positive inputs.
Okay, don't ask me why I forgot to make that arc cosine, but pretend that's an arc cosine, not an x. Here, I will make it happen. What's the matter? No, it's not letting me write. Okay, never mind.